Okay, start again. Hi everyone, my name's Mike. I'm a CTO for a company in Scandinavia that does DevOps consulting called Pragma. I'm here to talk about Agile and why I think it ushered in a new paradigm in the world of software, and why I'm really excited about it, and why I think that DevOps and continuous delivery are kind of really key to this whole thing. So the title for this talk and a lot of the ideas for this talk came out of reading this book. This is a book written by Thomas Kuhn in '68, and he at the time he was a PhD student in physics department in America, and as part of his duties he was teaching an undergraduate course for liberal arts students on the history of science. And what he came to realize was that the way we teach the scientific method is actually very different from the way science actually progresses. And he ended up summing this up in this idea of scientific revolutions and the history of them. Instead of science being an iterative progression, we're accumulating facts, it was much more about we go in paradigms and revolutions. And I have to admit, it's a really awful book. It's hard to read, it's very academic. I had to go through it 3 times to really catch it. So it's not really, I think I read the book so you don't have to is the message I'd like to give you. But even if it's a bad book, it has some really, really good ideas in it. And that's what I want to share with you. So going back to the way we all learned the scientific method at high school, the idea was that we would make observations, think of questions, formulate hypotheses, and if actually testable hypothesis, we'll run some experiments, gather data, and then iterate based on what we learn. And this is kind of considered the Popper method of scientific advancement. And Popper was very much about science as just being an accumulation of new facts and new facts and new facts. This is what his ideas were about. But Kuhn, he wanted to challenge that idea and actually says, well, if we look at the history of science, that's not actually the way things work. What he saw was that actually science goes through these revolutions at periods in time that completely uproot the whole field, and they have to start again from new foundations, and everything is washed away from the past. And to show this, he came up with this idea of the Kuhn cycle. What the Kuhn cycle says that, okay, normal science looks like the Popper method. It occurs within a worldview. This is the paradigm. Like scientists in a field exist within a paradigm, and their goal during their work is to bring nature and theory into closer agreement. And the important thing is that while working in this manner, scientists take the nature of their field for granted. The foundations are clear, the textbooks are known, there's a clear path to knowledge in this field. Some good examples of that recently that are kind of the bigger, more famous examples, like the Large Hadron Collider. This was a project that existed to try and see if we could find the Higgs boson, if it actually existed. And it found the Higgs boson. And the Dolly the Sheep experiment out of Edinburgh as well, it's like, we think we can clone a large mammal, and they did clone a large mammal. Basically, scientists tend to get the results they're looking for during this phase. Now, the problem is that in any paradigm, eventually there's anomalies that start cropping up, and they accumulate over time. Little pieces that don't fit within the paradigm, don't fit within the worldview, start cropping up, and they cause some kind of noise within the community. But the thing is, even if there's anomalies that don't fit in the current paradigm, the community will hold on to and maintain their worldview until there's something better on the table. They will not move or question the worldview unless they really have no other choice. But the thing is, eventually these anomalies accumulate and accumulate and accumulate until the field gets into a state of crisis. And this is when the scientists start to really have very robust conversations with each other. And this is a period where people start to question the foundations of the field that they've based all of their profession on. Now, the only way out of a crisis is with a new theory. And this theory provides this kind of revolutionary change in worldview. This is the revolution. And the important thing about a revolution is that it replaces the paradigm that was existing before. It has to provide a completely new paradigm. And this is where the term paradigm change comes from, or paradigm shift. Excuse me. It's actually from Popper that we get this phrase. The important thing about paradigms, and we'll relate this to software later, is that there can only ever be one paradigm in a field. And those that hold on to the old paradigm, retain the old thoughts, they're simply read out of the field. They're no longer relevant in their field. They're basically ignored. So it's quite a rough process, this revolution. So what he saw is that if we look at the history of science, this is normal. This is what normal science looks like. We go through periods of paradigms, revolutions, paradigms, revolutions, and this is not a bug. This is a feature. This is the way we make progress. So just to give some examples, there was a time when we had this geocentric view of the world. I mean, we're obviously the center of the universe because everything is flying past us in the sky. It makes perfect sense. And, we shared this belief for a long, long time. Until Copernicus thought, well, hold on, wait a minute. A lot of the things we're seeing in the sky would make a lot more sense if, the sun was the center of the universe. And that wasn't quite right either, but it was closer to the truth. And Kepler actually made a lot of observations, the Rudolphine tables, that actually gave good quality data that could actually match with this world, this paradigm that Copernicus was proposing. So it was a very violent change going from geocentrism to heliocentrism, but it was one that was inevitable. And once everybody came to accept this new paradigm, there's still a few people in the world that think the Earth is flat, but except for them, we all agree that things are more towards the heliocentrism than geocentrism. Now, it was about 50 years later, we had another revolution, again in physics, where Newton said, well, hold on, what about if the way objects behave, physics behaves on the Earth is the same as the way that physics behaves in the sky? What if there were universal laws of gravity, so that the way we throw a ball is the same as the way the planets orbit? Wouldn't that be an interesting idea? And then we get Newton's laws. Again, provides a completely new paradigm for physics. And Newton's laws lasted us a long time. That paradigm took us all the way to Einstein, basically. You could say maybe Maxwell, but definitely Einstein. Things started to change again, where I thought, okay, Newton had a lot of things right, but he wasn't perfect. And one of the things he believed was that space and time were kind of fixed. And what Einstein says is, well, hold on, maybe time is kind of a bit more bendy than we think. And, it can be affected by gravity and mass. So when we get the next revolution that goes on and gives us GPS and all these other lovely things that we treasure now. So that's just one field, one example. There's many more, but you can start to see in between these big points, these revolutions, science exists in those paradigms for quite some time. Trying to tie this back into the world of software, I mean, when I saw the ideas in this book, it became clear to me that even if our field is a lot younger, we've seen a lot of this kind of pattern in our field as well. Maybe not as many because we don't have the history as physics does, but still quite the same. I put the birth of our field really at during computation. You could go back to Babbage and Lovelace, but I think that really it starts with programmable machines. So quite young. This is the late 30s. I think 38. This paper was presented. So yeah, we're 80 years into our profession. Happy birthday. But it wasn't that long after the birth of software that we started to see our first crisis. And it was actually called the software crisis at the time. And this is Dijkstra talking. And he said, as long as there was no machines, programming was no problem at all, of course. Then we had a few weak computers. Programming became a mild problem. Now we have gigantic computers. Programming's become an equally gigantic problem. These were huge machines back in 1968. So they were struggling with complexity. Basically, there was a big problem that the machines were getting bigger and bigger, and the software was getting bigger and bigger, but they didn't have the tools or the techniques for dealing with this complexity. Basically a scaling issue. Now, at the time, what they thought the solution was is kind of hinted at, because this quote is coming from the NATO Software Engineering Conference in 1968. And what the belief was, and what held to be true, was that if we just engineered our way out of the problem, this would be the solution. If we take the practices and principles of engineering, then maybe we've got a way forward. And that's what I would argue is our next paradigm. There was the early days, the geocentrism, then we get the Newton's laws. What about if we applied the techniques and tools of civil engineering to software? That would help us solve this complexity problem that we're facing. We can make some plans. We can do some requirements analysis, do a design document, an estimate so that we know how much budget we need. We implement it, and of course we're going to test the bridge before we put any trains across it. So this is very, very similar to what we're thinking about in terms of software. We're going to have this kind of life cycle that's going to make sure that we go step by step and follow the engineering principles. So we got structured systems analysis and design. We start to do top-down composition, data hiding, and all other kind of things that we've come to understand were good practices. They came in this period between 68 and 98, I would say. And it was phenomenally successful. I mean, if you look at the progress we made as a field between 68 and 98, it was huge. It was really something. But then again, we were still facing scaling issues. And anomalies started to creep up. This is my all-time second favorite Wikipedia page ever. My number one is the list of cognitive biases, but this one is number 2, and it's lots of fun. It's the list of failed software projects on Wikipedia, and obviously it's not got every failed software project because it would be never ending, but it's got some real highlights, and the one for me that's closest is the NHS for Connecting Health. This is a UK. There's quite a few on this list from the UK. This is only a brief segment of it, so don't think it's only British people can fail at software. But so the NHS for Connecting Health, they spent £12 billion, which I guess in your money is what, $20 billion? It's a lot of taxpayer money. A lot of taxpayer money. And the important thing is this is in the section of the page called permanent failures, which means no value was ever gained from this software. It was never used. It's not used. £12 billion. That's terrifying. How is that possible? And there's a whole list of these projects. The thing about these projects that I find really interesting is that, I mean, they were following best practices. You know, they were outsourcing to really competent, top-grade consulting firms. They were using CMMI level 5. They had good requirements documents. I'm sure they were following all the right procedures. I actually met a guy. I was recently working in Perth, and I gave a version of this talk, and he sent me an email after, and he goes, "My wife was on that project. Do you want to have coffee?" Like, yes, I want to have coffee. So we had a very, very great discussion. I met his wife, and she was telling me all about the project. She was working in the health service somewhere in London at the time, and being part of trying to roll this software out. And it's exactly how you would expect the story to be. I'm not going to divulge too much about it because that would be a breach of confidence, but fascinating story. Someone should write a book about it sometime. But anyway, so we've got these anomalies start creeping up. We're doing the engineering thing, but we're still failing, and we're failing spectacularly. And there's other anomalies cropping up as well. There's other big, massive software projects that are doing just fine without following any of this engineering nonsense. You know, GNU didn't have a design document. They don't have a change advisory board. They don't have a group of architects deciding things. They don't have a process. Linux is massive, the biggest open source project in the world. It was doing just fine without any of this. And then there was other kinds of anomalies where people were saying, well, hold on, maybe we don't need to do this big waterfall thing. Maybe we can just do this iterative thing. And maybe we've just got the wrong paradigm. Maybe we're thinking the wrong thoughts. What if, instead of being bridge builders, civil engineers, we're just people on a factory line? It's not maybe as compelling a story. It doesn't make us feel big and proud. It doesn't make us get that extra pay rise. I'm not a chief architect anymore. I'm, a line worker. How did this happen? But what if the principles that manufacturing had been developing, especially in Japan, were the way forward for us? Wouldn't that be interesting? So this is where we're getting to the crisis. We have all these anomalies, and the only way to get out of a crisis is with a new theory. And it wasn't that long after we got a new theory, the Agile Manifesto. And this was a bunch of people who had spent 10 years arguing about the best way to make software, finally getting together in a room and deciding they had something in common. So they came up with these 4 values about, really what would this agile thing look like? How does this iterative thing, how do we get away from this engineering thing and get more to the lean thing? So they came up with this Agile Manifesto, and it was quite incendiary at the time. The other thing that was quite interesting is that there's not a lot of detail in here. Working software over comprehensive documentation. Sounds great. Responding to change over following a plan. Awesome. How do we do that? It's not so easy, right? So a little bit later, they I think 9 months later, they kind of crowdsourced principles behind the Agile Manifesto. And for me, the first principle is the most important one on that list of, I think, 15 principles, is that the highest priority is to satisfy the customer through early and continuous delivery of valuable software. And this is actually the first time that the term continuous delivery cropped up anywhere. But it's great. So we're going to satisfy the customer by giving them continuous delivery of software. Sounds awesome, right? But again, there wasn't a lot of detail on how we would do that. It's just a theory. And the theory is enough to spark the revolution, but you need more than that. So a theory is not enough. A revolution requires some achievements. You can't just say, I think it would be better if we typed upside down from now on. Because that's a great theory, but there's not a lot of evidence for that actually being a successful strategy. So going back to the structure of scientific revolutions, the books, one of the things Kuhn says is that a theory is not enough. You need achievements. And the achievements have to be sufficiently unprecedented. Basically, they have to be so impressive, the results have to be so impressive that it attracts people away from the existing paradigm. So that's one thing. You need really incredible results. And you also have to have, this is where I think the Agile Manifesto was really, really genius and very, very important in the history of software, was because it was really open-ended. There wasn't a lot of detail. And the nice thing about leaving lots of open-ended problems is that the thing that scientists and engineers and technologists all love is problems. Don't come to an engineer with a solution. They're not interested. They want to solve problems. So come to an engineer with a problem, then they get interested. So we had all these open-ended questions about how we would actually do this continuous delivery. Very interesting. But then we started to see people were actually doing it and getting a lot of achievements. I think the very first large scale, we started to see all the .com stuff exploding, but we also saw companies like Flickr saying, oh, we're deploying a production website with millions of daily users 10 times a day. And that was considered quite incredible back in 2009. Not long after that, these ideas of agile IT, agile infrastructure, bringing the dev and the ops together, the DevOps conference, books like the Phoenix Project. There's more and more stories coming out that actually there's something here. So now we have a bit of a working theory to frame our revolution. Now, if the internet's kind, I'd like to show you a video. So, you can think of this as a developer working away, making their software. I'm going to set this to production. Here you go, ops. There you go. Done. It's a bit of a joke, but you could also see that from the perspective of maybe that's the business analyst throwing stuff over the line to the development team. Or you could say it's the IT operations sending it over the line to the support team. Or there's any number of silos you could use this video for. But in essence, what we realized was that actually, if you're going to get anywhere about doing this continuous delivery thing, you can't have silos separated by queues. You need to have a flow-based mindset. And again, that's where the ideas of lean manufacturing come back to where we are. So there's also a role for tools in science. And obviously there's a big role for tools in science. But the important thing about revolutions is they give you a really good excuse to retool. And I can't count the number of companies I've worked with that use the opportunity of adopting DevOps to also go to the cloud, for instance. Because, well, if we're already going to do the work, we might as well go where we'd like to be. And it's a big change anyway, so we might as well just ask for the budget and the future we actually want. So these revolutions are actually quite useful for us to be able to affect some change in an organization. Going back to science, without the telescope, Kepler couldn't have gotten all the data that went into the Rule-Dauphine tables, and they were instrumental. Without those, Isaac Newton's laws of gravity couldn't really be proven because we needed accurate numbers on the motion of the planets. It just wouldn't have happened otherwise. Same thing with the microscope. It was in the 1830s when we finally got cell theory, but that was only because Zeiss had been able to manufacture lenses that were good enough to see at that level of precision. But step by step, you needed the tool to get anywhere. There was a time in our history, actually not that long ago, where to find out what was wrong with us internally, you had to be cut open when you were dead. That was how we figured out what killed you. So there was no real idea of non-invasive diagnosis. Now, what René Lanac realized was that the sounds, a lot of doctors had this kind of technique for putting their head up against the chest and back of their patients to hear what was going on. So they developed this stethoscope so that he could hear better. And then, well, what he did was he spent quite a lot of time listening to people who were sick, writing down what they sounded like, and then when they're dead, figuring out what was wrong with them, and then publishing those results. But then, step by step, we started to figure out, oh, this sound is tuberculosis. So we've got a whole new idea of how we can do things. Without the stethoscope, that couldn't have started. I can stretch this really far. I don't mind stretching a metaphor really far, but this is maybe a bit far. So without the tools like compass, navigation, ocean-going vessels, you wouldn't have had the Eagle expedition, which is where Darwin gathered all the data for him to come up with his theory of evolution. So you see it again and again. It's the tools and the data and the theory. They all have to go together. Sometimes it doesn't go tool, data, theory. Sometimes it goes backwards. So the Higgs mechanism was first postulated in 1964. But it took until 2008 before we had the tool to actually gather the data which proved it. So sometimes it goes in other directions, but you can see you need all three to make progress. So tools and data and theory, you need them all together to sustain a theory. And this is where we get to Agile. So we have this theory that Agile improves business outcomes, or even continuous delivery improves business outcomes. But where are the tools and the data? I mean, it's at least until 10 years ago, it was still just a theory. But a lot's happened in the last 10 years. There's been a lot of tool development. This is a tool that was coming from the world of manufacturing that we brought to the world of software, which I hope will work. No. Okay. But I can give you the gist. So, it's the Andon Cord. The Andon Cord was really, really important for for Toyota and the way they developed their factory lines. Their production lines have an Andon Cord everywhere, and if anyone on the production line sees something wrong, they pull the Andon Cord and people swarm on the problem. It's really, really important. And what they found is that there's two things. One is you don't want to pass defects on to the next step in the process because it becomes much, much harder and it destroys any flow. But the thing is, it's not enough to have the tool. You also need the culture that goes along with it. If you want to empower people, you have to be strong enough and committed enough to follow the rules. So that means that even if there's pressure to deliver, you don't deliver crap. You stop. The line is pulled. Because if someone pulls the line because something isn't right, you swarm on the problem and say, we'll fix that later. Then guess what happens? Next time they don't bother pulling the Andon Cord. It's all about the culture. And there's lots of stories in the lean manufacturing world about companies that have tried to implement the same systems and processes as Toyota, but they've completely failed because they didn't adopt the culture as well. So we also have this idea of an Andon Cord in software, and this is our continuous delivery pipeline. The whole point of a continuous delivery pipeline is to take code from it being ready at the developer's perspective to it being actually shippable, ready for the customer. And the idea is that everything in between should be low variability and should be automated as much as you can. So you want to keep that as a very predictable pipeline. Now the problem is, there's a lot of different ways to implement this. Some companies are very, very aggressive, and if the Andon Cord goes red, everyone swarms from the problem, they fix it, and others, the culture is not quite there yet. So it's not enough to have Jenkins, it's also the culture and so on that goes around it. How many people are using more than 3 of these tools right now? Or any of these tools then? Right. These are all made in the last 10 years. These are all tools we've created recently to solve the problem of how do we continuous delivery software. And this is just a small subset. If you looked at all the DevOps tools possible in the world, it would be massive. But that's one of the nice things about our field is that making tools is a problem we know how to solve. We're really good at that. So we've got all the tools we need, and we're getting more and more tools all the time. Nice thing about tools is that we shape our tools and thereafter they shape us. So as we adopt infrastructure as code, well, guess what? We start to be more agile in the way we think about how we create deployments, how we're going to scale. All other things change about us when we change our tooling. It's very, very interesting. But of course, it's not enough to automate everything, it's not enough to automate everything, to make everything part of your delivery pipeline. You also need to change your org. You need to have empowered teams. And from the world of DevOps, an empowered team is that a team doesn't depend on another team to deliver their work. Because as soon as you have another team that you're depending on, guess what? You have a queue, you have conflicts, you have culture wars, you have us and them. It doesn't work. It goes against flow. So as much as possible, anytime you can, you want to have empowered teams. Right. So we've got the tools and we've got the theory. Next, we need some data. If Agile really does improve business outcomes, where's the data for it? There's lots of people saying it. we can all get nice and warm and fuzzy about Scrum and Agile and so on, but where's it on the bottom line? Well, for me, Dora and Puppet have done some really, really important work on this over the last 5 years, and they've actually gathered data by surveying thousands of IT professionals across the world every year. And they design their questions in such a way to test specific hypotheses they have about DevOps and continuous delivery. They publish the results every year in a State of DevOps report. Now it's split off into 2 State of DevOps report. I think that there's been a divorce, and now Puppet is doing one thing and Dora is doing another thing. But anyway, the methods are very, very sound, and a lot of the results from this work are published in peer-reviewed journals as well. So it's really given us the glimpse of the start of a data culture around this Agile improves business outcomes. And they can see, we all know that there's a distribution of effectiveness on the IT range, but they can actually put numbers on it, and they say, well, there's the difference between the low performers and the high performers in terms of deployment frequency, lead time for changes, mean time to recover, and change failure rate. Obviously, there is going to be a distribution of outcomes. What for me is also very interesting is that these 4 measures are super easy to measure. Any one of you can do this in your organization with just a few conversations over a coffee. You want to know what your deployment frequency? Well, look at your service manager, or look at your Octopus deploy. You want to know what your lead time for changes is? Well, look at how often you deploy versus when the commit was made. Mean time to recover. Again, all this stuff you probably already have the data for. There's nothing magic here. And if this is easy together, then why not do it? Here's a good reason why you should do it. Let me just simplify this. This is a structured equation model coming from the State of DevOps report in 2017. For me, this is the most important diagram that has come out in the last 10 years in software, because what it does is establishes cause and effects with performance drivers. So here, every time you see an arrow, that is indicating a predictive relationship, not a correlation, but a predictive relationship. So I'm just going to simplify it a little bit and say, what they're doing is they're tying all their hypotheses to financial outcomes. So everything else they're testing for, they're also finding out the financial performance of the organizations that the survey respondents are coming from. So they can see that high-performing IT organizations actually have better financial outcomes. This is the most important result of any research in software that I can think of in a long time. If you dig into it, well, they say that organizational performance is, IT performance predicts organizational performance. So if you're good at IT, you tend to be good financially, and if you're poor at IT, you tend to be poor financially. And the 2 things that are most predictive of IT performance are whether you're doing lean product management, which if you look at the concepts or the capabilities that are in that box, they're really about Agile, getting close to your customer, small batches, and team experimentation. They look very close to the same things that you would see in the Agile manifesto. But the other thing that affects IT performance is continuous delivery. So what they're saying is that lean and continuous delivery, Agile, all that stuff is kind of under the bucket of DevOps for them. But anyway, to do continuous delivery, you also need a lot of practices. You need to be able to do continuous integration. You need to be able to test your software automatically. All these things predict continuous delivery. Another thing that's really important about this research is that it shows that none of this works unless you have transformational leadership. Like, if you try and do this from the grassroots up, it's almost impossible, because all of this stuff requires investment or org change. Culture change, org change, and investment don't come unless the leaders are on board and interested. So you have to start all the way over there with transformational leadership. How many of you have seen this before? Okay, but that's good. I'm glad you've seen this. This is, if you remember anything from this presentation, please, this is it. So yeah, this stuff is really easy to measure. You can do this. You can do this with your team in 5 minutes. So I really recommend you take those measures and use them to identify whether you're improving or not. one of the things I sometimes do with technology organizations is to map out the value stream from the need all the way to the customer getting what they want. And you'd be surprised at how many people you typically need to have in that room to make that work, from all different kinds of teams. You'd be surprised at where you find silos in your organization, so it's worth digging into it. Now, just to follow up a little bit on the financial side of this, because yeah, it's easy to be cynical about these things, but there's actually a guy, Eric Minnick, who's been personally investing his own money on the stock exchange, on companies that are publicly talking about and focusing on DevOps and being successful in DevOps. And he's made a load of money by doing that. He's basically invested a whole portfolio of his own personal money based on how much people are talking about their DevOps transformations in conferences, basically. And what he said is that, well, my portfolio was up 113% compared to the S&P average of 31%. So he's getting real alpha on this just by looking at who's talking about DevOps. I think that's fascinating. Okay, so by now I'm sure you're all excited about DevOps and what that means for you. So what should you think about when you're trying to do any of this stuff? I think one of the things to realize is just now that what we're seeing now with DevOps and the cloud is a complete reaction to really where this paper started. IT Doesn't Matter by Nicholas Carr in 2003. And what he was saying is that IT doesn't matter. It's just compute. It's just storage. It's just networking. It's all commodity. There's no business advantage in any of this. You should outsource it. And loads of people did. How did that work out? Not super well. And there's actually, the Dora team have been starting with asking about outsourcing in their surveys. And of course they're finding that software delivery performance is reduced when you do outsourcing. And we all know that. We've all heard about companies where it takes 6 weeks to get a virtual machine. And the thing is, Nicholas Carr wasn't completely wrong, because of course compute and networking and storage is commodity. But that's not what you're really paying the IT budget for. You're paying it for the people who are skilled. And where can you get all that compute and network and storage anyway with a credit card? It's on the cloud. So he was right in the long term that, you know, the physical aspects of IT are becoming commoditized and will be outsourced, but not the people. You need the people if you want to get anywhere, because the people are key to any of this. Okay, I said if you remember one slide, but actually I meant one and one more. This is another one. This was a paper written by I think they were consultants from Bain, but it was in 2008 in Sloan Review. It was the MIT Business Journal. And it was called Avoiding the Alignment Trap in IT. It's a great paper. It costs about $6 to get, and I really recommend it. This is all you really need to know about it, is that what they did was they spoke to 500 people who were executives in S&P 500 companies. And they said, okay, they ask a lot of things, like what was your financial results? How much do you spend on IT? How aligned is your IT organization with the business needs? And how efficient, how effective is your IT organization? So what they did was they put these companies in clusters, like the Boston box, the four quadrant model. And they said, well, most respondents said that their organization were in the maintenance zone. They were basically spending money on IT to keep the lights on. And they spent about average on IT, and their sales weren't really that different from each other. And they said, well, obviously people in the top right, and everyone wants to be in the top right in any quadrant model, and there it's called IT-enabled growth, where the IT organization is both highly aligned with the needs of the organization and highly effective. And what they found is that the companies up there tend to spend 6% less on average on IT, and they tend to be 35% higher in terms of 3 year sales compound annual growth rate. that's fine. Everyone wants to be there. Then down in the bottom right, we had well-oiled IT, where the organization isn't really very aligned. The IT organization isn't very well aligned with the business needs. They do whatever they want, is kind of what the executives think. Those guys do whatever they want. But guess what? They tend to spend 15% less on IT than everyone else and have better sales results. So maybe having an IT organization that just does whatever it wants is actually a good idea. It's a strategy, right? And then the title for the talk for the paper was the alignment trap, and that's the top left quadrant, where the IT organization was highly aligned with the business needs, but they didn't really get much done, and that's because they're in the alignment trap. And there they spend 13% more on IT, and they tend to have 14% worse financial results. The reason why it's called the alignment trap is obvious. Once the business gets a control on what the IT organization is doing, that's basically what alignment means, then how much is going to get invested in getting off the legacy platforms, doing the continuous improvement works, all those other things that are easy to neglect? All the money goes on features. Everything goes on features and value. And the people deciding don't understand the value and risks of all the technology choices that are being made because of this. They call it the trap also because it's hard to go from the top left to the top right. In fact, what they found was to get to the top right, everyone went through well-oiled IT first. They went right before they went up. Because if you get rid of all your legacy systems, improve your processes, get effective, then it's quite easy just to listen a bit more. But once you're listening, it's really hard to carve out the space and time and budget to get better. This CIO said it best, I think. Aligning a poorly performing IT organization to the right business objectives still won't get the objectives accomplished. And that's interesting as well, because I see a lot of companies that they start their digital transformation by reorging the company around some kind of scaled agile model where they have tribes and squads and the business people in with the techs. That's alignment. You're solving an alignment problem. You have to be careful you don't fall into an alignment trap if you go down that path. Andy Grove has written many good books. This one, he was the CEO of Intel. He was an engineer at Intel and worked his way up to becoming CEO. Very, very smart guy, influential thinker in Silicon Valley. And this book is about Only the Paranoid Survive. It's about the transition from Intel being in the memory business to it being in the CPU business. And what he was seeing at the time was that while in Asia we get a lot of competition, they can build memory better than us and cheaper than us, and it's a commodity, it's going down, 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 down. But we have this CPU thing that has a future, but none of our business or incentives or culture is set up to focus on it. So this whole book is talking about how he kind of realigned the whole organization from one business model to another. It's a great book. In it, he talks about a strategic inflection point, and that was what he saw. Is like if he doesn't do something now, he's going to the Intel business is going to diminish and decline and never recover. But there's also an opportunity to go on to the next business. And I think we're seeing this a lot in these companies that are doing digital transformations, where they're insurance companies or banks or very, very traditional industries, been around for hundreds of years, shipping, all of it, and then they're suddenly realize, well, if we're suddenly going to compete with anyone that's got a laptop, we need to think different. I think that more and more organizations are starting to realize that if it's not a strategic inflection point now, it's soon coming. So that's a very fun time to be in the software industry. So this is good news. This is good news, even if it does sound bad news. The future is here. It's just not evenly distributed. So you want to, obviously you don't want to be a first adopter with all the shiny things, but you don't want to be the last to adopt. Yes, it's safe to use the cloud. Just learn how to do it safely, for instance. And you want to plan for replaceability. You don't want to plan for your software systems to be on a particular platform. You want to plan for a future that evolves. And obviously learning from the community. There's a lot of people working in this space, so we should learn from each other. So that's it. That's my theory. I believe that DevOps defines our paradigm, or at least Agile defines our paradigm, but DevOps is really the bit that makes it actually a true statement. Like Agile is the theory, and DevOps is the practice that you need to actually do it. And I think we're through the crisis. We've had our revolution. Nobody's going back and thinking, I really wish we could go and do a requirements document again. You know, there's not a lot of people yearning for the old days of software, right? So we have entered a new paradigm, and those that really do believe in waterfall, they've simply been read out of the profession. So now we're kind of in this normal period. It's like tools and data is what we need to focus on. Make sure we're making our decisions based on good data and build the tools that we need to deliver. That's it. Science, it works. Thanks for listening. Appreciate it. And I'm sorry for the late start. If there's any questions, I don't know, is there time? Yeah, if you have any questions, I'm happy to take them. Yeah.
So I feel like I can help out at my work with getting DevOps and continuous delivery, but I feel a bit powerless with the alignment trap, and I've never heard that concept, but it fits so perfectly. Where isn't that all about the very top people deciding to invest in non-business objectives for the IT firm? If they don't see the value in that, how do people at the bottom fudge that?
Right. So just to rephrase, so how do people at the bottom have an effect on the alignment trap problem? I think it's really hard. And if we go back to the structured equation model from Dora, that's why transformational leadership is so important. You need to incept these ideas at that level and explain to them why it's so valuable. Because I think that there's a lot of press about Agile and how important it is, and how it's important that we're aligned to customer outcomes and all of this stuff. But they're not hearing a lot of voices saying, yes, but actually we need to invest in really effective technology. And I think that we all in this room have to do our bit to talk at the executive level about why this is important. That's what I see my mission is right now, is just making sure everyone remembers that the technology is still important. Because yes, you need the customer, and their outcome is important, but without the technology, it's nothing. Yeah.
Do you have any story of a company who escaped from that trap? I just try to understand a little more.
So how to escape from the trap? There's plenty. Yeah.
Real world case.
Yes, actually, the paper has the paper's from 2008, so a lot of the examples there are not very relevant anymore. But I see it all the time, where what companies do is they decide to take on a legacy problem or create a new platform to the side of their existing business. So they'll form a tribe or another part of the business that will be like, doing their cloud native adoption process, and they'll be so far from customers. Like there's just no way that all their input is coming from the technology and what they can achieve and how they can get there. So I think it's about carving off a part of the company that just goes at the bottom left and goes, we're just going to try and find something really effective over here with technology, and we're not going to listen to anything from the customers. So funding those kind of projects internally is important. Again, this is where I think these revolutions are important, because if you get to the stage where you think, we need to go to the cloud, then it's hard to say, we need to go to the cloud, but also be 100% focused on our customers, because that doesn't work. You can't have both. You need to carve off some part of your resources to go and work on the cloud stuff away from any of the noise of customers. Does that make sense?
It does.
Yeah. Okay, but thanks. I appreciate it. I'll be around all week, so just shout if you want to talk.